Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad SOLEHIN bin JUNID. My matrix number is 2023686096. My supervisor for my research is Dr. Maizah, and my research title is Assessment of 3 Carbon Stock in UiTM PERLIS using integration of geospatial methods. Let's move for the first thing. The abstract of my research. Carbon stock represents the total amount of carbon stored in trees and plants, serving as a critical indicator for understanding forest carbon sequestration and combating climate change. Data collected from the field is about 31 samples reveal an average above ground biomass, or we call it AGB, of approximately about 14,513 kg, ranging from 4,038 kg to 37,935 kg. Correspondingly, the carbon stock was about 6,590 kg, with average of with a range of 1,898 kg to 17,829 kg. Okay. Analysis show a weak corresponding between UAV-derived crown projection area and AGB, which is R is about 0.204 and R square is 0.042. So this indicating limited predictive capability of crown area alone to predict AGB. In contrast, the tree heights obtained from UAV data demonstrate a moderate corresponding, or we call it correlations, okay, with carbon stock, which is R is about 0.480 and the R square is 0.203. Okay, suggesting that while taller trees tend to store more carbons, height alone explain only 20% of variations in carbon stock. The study highlights the variability of carbon stock across sites and underscores the value of integrations. Okay, the value of integrating UAV-based RGB imagery with ground measurement. Furthermore, the evaluations of OBIA, or we call it object-based image analysis techniques, confirm its effectiveness in tree crown detection, and the identifications of UAV-derived parameters provide promising avenue for enhancing biomass and carbon stock estimation models. These findings contribute to improve the forest monitoring and management strategy aimed at a climate change mitigation. So let's remove for the background of study. For the background of study, forests play a crucial role in the global carbon stock cycle by absorbing CO2, which is carbon dioxide, and acting as a carbon sinks. Measuring tree carbons is vital for understanding of forest ecosystems and mitigating climate change. As we know, traditional field-based biomass estimation is accurate absolutely, but often costly and time-consuming. Remote sensing technologies, especially an unmanned aerial vehicle, or we call it UAV, using the photogrammetry, RGB, and LiDAR, offers precise, high-resolution data for estimating above-ground biomass and the carbon stock. UAV are effective for monitoring tree height, canopy structure, particularly in the difficult terrains where field measurements are challenging, absolutely because of the geographical. This study focused on using UAV-based RGB photogrammetry to capture detailed canopy image and generate 3D structure for the biomass estimation. The research at the University Technology Mara, or UiTM, UiTM PERLIS aim to evaluate UAV remote sensing as a fast, cost-effective tool to support sustainable forest for the sustainable forest management and the climate change mitigation. Let's move for the problem statement. Due to the urbanizations, there is a fact of the amounts of carbon stock stored in urban ecosystem. Yes, because of the carbon emitted from the human technology like motorcycle, like car, and also like a factory. Next is the necessity for accurate and up-to-date data of a carbon stock, which is currently lacking because we are not often to get involved to get know about the carbon stock as the carbon stock in urban area. And also, as we know, the traditional method often required more time and also more cash, so we try to get the potential data that we can derive from the RGB UAV data. The significance of study is we want to mitigate the rate of the climate change in this country, and also especially in UiTM PERLIS, using the field measurements, and we try to get as many data that we can derive from UAV RGB. And also, we want to provide a valuable data for the formulations of the policies related to the sustainable land use and the climate change mitigation. For the aims and objective, the aims of the study is to assess the tree carbon stock in UiTM PERLIS using UAV-based RGB and object-based image analysis, or we call it OBIA, for improve the tree count detection in urban green management. So this is the pilot study. Okay, for the objective of this study is to identify three attributes in study area using ground sampling and UAV. Next, the second one is we want to evaluate the performance of OBIA analysis, analysis for the ground detection. And the third one is to define the potential parameters from UAV RGB data. For the methodology, first we do the planning, we do the research and plan, and then for the second phase, which is the data acquisition, we require to do the UAV data capture and also ground sampling, which is about the DBH, diameter at breadth height. First, second is the position of tree, and the third one is the height of tree. Entering the data processing, the data derived from RGB we use to construct the CHM, or we call it canopy height model, that required us to extract the DSM and DTM, which is the digital trend model and digital surface model, and then we use the formulation to minus two layer, and we come up with the CHN and extract all the three height, and then we do the accuracy of three height. So we compare with the ground sampling and also with the UAV derived data heighting of the tree. Okay, so we compare and we do the accuracy assessment. From the UAV data also, we use to do the segmentations. Okay, the segmentation is we want to segmentate all the three crown. So we use two software, which is NV and eCognitions. And these two software in the eCognitions, we use to do the multi-resolution segmentations, and in the NV we use the each segmentation full lambda. And next, we compare with these two data segmentation from NV and also in eCognition. So we try to choose the best with which one of the software provide the best segmentations and classifications of three crown. So we get that eCognitions, okay, we choose one, and then we used to do the refinement of the three crown, and then we come up with the outputs of the three crown net in UiTM PERLIS. Next we go for the last objective result, which is first we need to calculate the AGB and then the cover stop, and then okay, to achieve the objective 3, which is we want to see the potential, okay, data of RGB, UAV RGB in carbon stock estimation. So we use to do the correlation calculations, which is I have provided the plots, the scatter plot there, okay, scatter plot of the carbon stock, the correlation carbon stock, and also the tree height from UAV. And the second one is the carbon stock and projection, crown projection area. And also I provide the table, okay, the table that show the Pearson correlation, okay, for the interpretation of all the data, the plots, okay, the scatter plot I provide, and also the table is we can see the carbon stock and the crown diameter is weak positive correlation, okay, weak positive correlation, and also indicating no statistical significant correlation because of the Pearson's correlations value is about 0.2. And then for the carbon stock and the crown projection area also show the weak positive correlation, okay, weak positive. Bear in mind weak positive correlation, which is the value is 0.2.4, and also have no statistical significance. And last one is the carbon stock and tree height that we derive, okay, from the carbon canopy height model, okay, from the RGB data. So you can see they have a moderate positive correlation, okay, moderate positive correlation, okay, with the value of 0.480. Okay, so it also indicating statistical significant relationship at the 1% level. Alright, so here we are at the conclusion and recommendation. As we see all the things, yes, we are here at the conclusion and recommendation to sum up all the things, okay, to sum up all the things from the beginnings to the result and analysis. So we can see that the RGB UAV data that can be used, might be used, is the tree height from this canopy height model with the RMSE 1.280 1.28. Okay, and for the crown projection area and crown diameter, we can have a further detailed study on this. So maybe we can come up with a group formulation, okay, to to uh, to derive, okay, to get the basal area and also the crown projection area from the crown diameter, okay, crown diameter and also the crown projection area. So crown projection area, crown diameter area, derived from this data to calculate the basal area and also the DPH. Maybe it's not impossible, it's really possible, but have a lot of work to do, because it might require the detailed research on this to formulate the right formulation for the tree, okay, the tropical tree in Malaysia. So that's all from me. Assalamualaikum warahmatullahi taala wabarakatuh, and have a nice day.